Good morning, children. So, after a long time, again, our classes are going on. So, today I'm going to introduce the topic. The topic name is mensuration. Okay, 10th class SSC topic, mensuration, which is very, very important. Actually, this mensuration you people are doing from 6th and 7th onwards, you are doing. So, in fact, in 3rd and 4th also, so generally we practice these mensuration questions. But in 10th class, elaborately we will discuss. So mensuration completely based on application part. So daily life incidents. So the daily life incidents. So we have to apply every question for daily life incident. Then you easily can understand the sum. So especially in the mensuration, you have to understand the question. Okay. So once you understand the question, so analyze the question. Analyzing is nothing but understand the question. So when you this analyze the question, then you can do the sum very simple manner. Once you understand, then you have to remember some formulas. You have to apply some formulas. So want to apply the formulas means you need to know the formulas, right? So for that, so what are the formulas? So how to apply? What are they? So how many formulas are there? So let us discuss in this class today. First of all, so uh, a happy birthday to our great hero, Srinivasa Ramanjan garu. So actually, I want to do this video on only, but because of some reasons I couldn't complete it. As so on the behalf of Ramanujan sir's birthday, so happy Mathematics Day to everybody. Now coming to in the mensuration means the all the questions based on so diagrams. Which type of diagrams are there in our mathematics? So line, straight line, line segment, rays. So now coming to triangle, quadrilateral, parallelogram. So these all, so we have generally, so line segment, length of the line segment, these are in lower sections. Now, triangle based questions. Triangle based questions are sixth, seventh questions. Now, based on these, so triangle shaped objects, 3D objects, 3D objects in our 10th class. Let us know first of all, so how they will give on triangles, quadrilaterals and now coming to triangle, in triangle ABC, A opposite side is small a, B opposite side is small b, and C opposite side is small c. Understand? C opposite side is right. So these are the lengths of the sides. These are the lengths of the sides. Now, sum of the lengths of the sides is nothing but perimeter. Now, first area of triangle. Area of triangle ABC is equal to half into base into height. Half into base into height. And one more formula is there. Area of the triangle, that is Heron's formula. Before Heron's formula, what is the perimeter? Perimeter of triangle. Perimeter of triangle ABC. Perimeter of triangle ABC is nothing but sum of all sides. Sum of All sides. Very nice. Sum of all sides means so AB plus BC plus AC. So AB plus BC plus AC or A plus B plus C also we can write. A plus B plus C. This is perimeter. Now yes, sir. S is equal to what? Semi-perimeter. Semi-perimeter. What is the semi-perimeter? Semi-perimeter is nothing but perimeter by 2. A plus B plus C by 2. So semi-perimeter is A plus B plus C by 2. So perimeter, semi-perimeter. Now coming to again area of triangle ABC. So using Heron's formula is equal to under root of S into S minus A into S minus B into S minus C. It's very, very important. Okay. Now coming to equilateral triangle. In equilateral triangle, all the sides are equal. And perpendicular and median coincides. Median and perpendicular both are. So this perpendicular divides the base into two equal halves and also it is perpendicular. So now here area of the triangle, area of equilateral triangle, area of equilateral triangle, equilateral triangle ABC, that is nothing but half into base into height or root 3 by 4 a square. What is this a? Where a is the length of each side. It is area of equilateral triangle. Then what about h? Length of altitude, height. Height of the triangle ABC. Height of triangle ABC is equal to root 3 by 2 a units. So there is a proof is there, root 3 by 4 a square. Why area of equilateral triangle is root 3 by 4 and height of the triangle is root 3 by 2 a. So there is a proof. So in next video we'll discuss these proofs. Okay, right. Now coming to right angle triangle, very 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 important. So triangle ABC, in triangle ABC, so angle B is equal to 90. So one angle is 90 degrees, right? One angle is 90 degrees means the side opposite to the right angle is hypotenuse. So hypotenuse. So by Pythagoras theorem, by Pythagoras theorem. So, so we have Pythagoras theorem. What is the Pythagoras theorem? A square on hypotenuse is equal to sum of squares of other two sides. What is that? Square on hypotenuse means AC square is equal to sum of squares of other two sides means AB square plus BC square. This is very very important. You need to remember this. Now, suppose this is base and it is height. So naturally, area of the triangle ABC, area of triangle ABC here naturally half into base into height. Okay, fine. This is about okay. Now coming to what is this? It is a quadrilateral ABCD. Okay. So here ABCD is a quadrilateral, right? AB is a quadrilateral. Then what's AC? AC is equal to diagonal. So the diagonal length I am taking as D. Okay. Now see DP and BQ are heights H1 and H2. Two heights, two perpendiculars. Two perpendiculars drawn from the vertex to the diagonal, opposite vertex to the diagonals. Okay, now area of quadrilateral. Area of a quadrilateral ABCD, that is equal to half into length of the diagonal is a D into H1 plus H2. Okay, you need not remember this. So individually you can find this area of the triangle half into base into height, and the second triangle half into base into height. Then you can add like that also you can do. So you need not remember this. If you remember, it's well and good. Now coming to this is it's a parallelogram. So ABCD is a parallelogram. So parallelogram properties and all. So let us discuss in another class. So in plane geometry we will do that. So now right only it is related to areas and perimeters. Okay, it is what is this length? It is length. It is breadth. Again it is length. It is breadth. Okay. Now it is height. Now see area of pyramid, area of parallelogram, area of parallelogram. Area of parallelogram is equal to what? Base into height. Base into height. Base into corresponding height. Suppose if you have taken base as BC, corresponding height you need to take. Okay. Now perimeter. So perimeter is equal to sum of the sides. Sum of the sides. Sum of the sides. Now coming to what is this? See the symbols. These two sides are equal. These two sides are equal. So opposite sides are equal, and each angle is 90 degrees. So it is a rectangle. A rectangle. So what is area of rectangle? Area of rectangle. Okay. So it is length and it is breadth and it is length and it is breadth. So area of rectangle is equal to L into B. Now perimeter. Perimeter of rectangle. So perimeter of rectangle is equal to what? Perimeter of rectangle is equal to L plus B plus L plus B. Two lengths and two breadths. So 2 into L plus B. 2 into, very fine. Now what is there in the here? It is joined. Suppose if it is A, B, C, D is the rectangle, then what is AC? AC is equal to length of the diagonal. Length of the diagonal. So length of the diagonal I am taking as D. So D here Pythagoras theorem. If you apply Pythagoras theorem, D square is equal to C. D square is equal to L square plus B square. Hence D is equal to under root of L square plus B square. Length of the diagonal. Okay. Right. Coming to what is this? It's a rhombus. So in rhombus, so two diagonals are there. Two diagonals bisect at a right angle, 90 degrees. Diagonals are not equal. So first diagonal D1, second diagonal is D2. So D1, D2 are not equal. Here diagonals are D1, D2 comma diagonals. D1, D2 are diagonals. D1, D2 are diagonals. whereas all sides are equal. So sides are A, and A. It is right angle triangle, right? See this. Two diagonals, then its area of rhombus. Area of rhombus, that is equal to half into D1 into D2. Whereas it is a square. See, in square also all the sides are equal. The side which is A units. And diagonals bisect each other and diagonals are equal. So here area of square is equal to side square or A square or S square, whatever you feel easy. Okay, any formula. Now perimeter of square. Perimeter of square is equal to 4 into side, or we can write 4s or 4 into A. So what is the length of the diagonal? B is equal to under root of A square plus A square, or root 2A square, or root 2A. This is about square. Coming to 3D diagram. What is this? It's a cuboid. Cuboid. So cuboid L comma B comma H are length, breadth and height respectively. Then area of lateral surface area or area of four walls. Area of four walls. Area of four walls is nothing but lateral surface area. Lateral surface area. Lateral surface area is nothing but 2 into H into L plus B. 2H into L plus B. Now, total cuboid contains 6 faces. So, here only 4 walls and a top and bottom. Top, bottom. Top, bottom contains two more faces. That is, we can consider as 2 more faces. So, if you consider 2 more faces, so that is total surface area. So, now total surface area. Total surface area is equal to 2 into LB plus BH plus HL. Now coming to its volume, volume is equal to L into B into H. Area of 4 walls, total surface area and volume. Area of 4 walls is nothing but LSA. LSA means lateral surface area. Total surface area is nothing but TSA. Volume is V. That's it. Now coming to cube, where in cuboid length, breadth, height are different. In cube, all length, breadth, height are equal. L is equal to B is equal to H is equal to side A I am taking. That is cube. In cube. Okay. Now area of four walls. Area of four walls or lateral surface area. Lateral surface area. So that is LSA is nothing but 4A square. Okay. Whereas TSA, TSA means total surface area. total surface area. Total surface area is nothing but 6a square. Now coming to volume. Volume is equal to A into A, length, breadth, height. So A cube. So area is in square units. Same as this is also same square units, and volume always is all units of volume is cubic units. This is about. Now coming about cylinder. What is the difference between cuboid and the cylinder? Cuboid surface is base is circular, then it is cylinder. Okay, right. Now cylinder. Okay, cylinder. So cylinder base, its base is circle. Base is a, so base area means area of the circle. Area of the circle. Area of the circle is equal to pi r square. Now what about this LSA? LSA of cylinder. LSA of cylinder. So LSA is nothing but perimeter of the base into height. So perimeter of the base is nothing but perimeter of the circle 2 pi r into h. Now TSA, total surface area, is nothing but LSA plus 2 into base area. 2 into base area. LSA is equal to 2 pi r h plus 2 into base area pi r square. Finally, 2 pi r is taken common. 2 pi r is taken common. Then h plus r. This is THA. Then coming to volume. Volume of cylinder is base area into height. Base area into, that is equal to pi r square h. This is about cylinder. Now coming to cone. So there is a maximum very nearest relation between cylinder and cone. So let us see what is this here. Cylinder cone means joker's cap, ice cream cone. So only one, it contains only one base, and another one is sharp end. Okay. The cone, the line joining the vertex to the center of the circle is height, and this is r, and this is slant height. So in right angle triangle, already we have discussed Pythagoras theorem. So L is equal to slant height L is equal to slant height. L square is equal to r square plus h square, whereas L is equal to the root of r square plus h square. Now LSA of cone is equal to pi r L, and TSA of cone is equal to LSA plus only it contains only one base area that is equal to pi RL plus pi R. Hence, if pi R is taken common, L plus R. Whereas volume, if you take volume, if you consider volume, what is the volume? LSA is parallel, TSA is equal to pi R into L plus R, and volume. Volume is equal to 1 by 3 into volume of cylinder. That is equal to 1 by 3 into pi R square H. This is about cone. Coming to sphere. Here is very simple. LSA or TSA. Both are equal to 4 pi R square. Volume. It's a sphere. Volume is equal to 4 by 3 pi R cube. Now coming to here R is the radius. Coming to hemisphere. Hemisphere base radius is R and height is R. Here radius is R, height is R, R, 2R, R plus R, 2R. Here hemisphere CSA. So there I am using LSA and here CSA. So both are same. So it is curved area. That's why I am consider this LSA as CSA. CSA is equal to 2 pi R square. So whereas it is 4 pi R square, it is 2 pi R square. TSA, CSA plus 1 base, 3 pi R square. Now volume is equal to half of volume of sphere, 4 by 3 pi R cube. That is nothing but 2 by 3 pi R cube. Okay, so these are the formulas mainly used in solution. Okay. As below, so area of the triangle is half into base into height, or if sides are given under root of s into s minus a into s minus b into s minus c, where s is equal to semi-perimeter is equal to a plus b plus c by 2. Perimeter of the triangle is equal to sum of the sides, that is ab plus bc plus ac, or small a plus small b plus small c. In the same way, area of equilateral triangle whose side is small a is equal to root 3 by 4 a square. Very important. Area of equilateral triangle is root 3 by 4 a square. The same way, height of the equilateral triangle is h is equal to root 3 by 2 a. Altitude, length of the altitude, it is root 3 by 2 a. Now coming to area of the quadrilateral, half into d into h1 plus h2. h1 and h2 are perpendiculars drawn on diagonal. D is the diagonal. Area of the parallelogram. Coming to area of parallelogram is base into corresponding height. Area of rectangle is equal to L into B. Area of rectangle is L into B. And perimeter of rectangle is 2 into L plus B. Perimeter of rectangle is 2 into L plus B. And length of the diagonal of the rectangle is D is equal to under root of L square plus B square. Area of rhombus is equal to half into D1 into D2. Area of square is equal to side into side, or side square, or a square. Perimeter of the square, 4 into side, or 4s or 4a. This is a length of the diagonal of the square is root 2a. The length of the rectangle is d is equal to under root of L square plus b square. Here length of the diagonal of square is root 2a. Now coming to cuboid. LS of cuboid is equal to is nothing but area of 4 walls. So 2h into L plus B. TSA is equal TSF cuboid is equal to 2 into LB plus BH plus HL. 2 into LB plus BH plus HL. Volume of the cuboid is equal to L into B into H. Same way, diagonal of the cuboid is equal to under root of L square plus B square plus H square. Now coming to LSA of cube. So area of four walls of the cube. So all faces are congruent. So hence 4a square. 4 walls, 4a square. PSA of cube. Total 6 faces. Area of 6 faces is nothing but 6a square. Volume of the cube is a cube. Side into side into side. Diagonal of the cube root 3a. In the same way, cylinder. CAC of cylinder is equal to 2 pi r h. PSA of cylinder is equal to 2 pi r into r plus h. Volume of the cylinder pi r square h. Base area into height pi r square h. In the same way, cone. Coming to cone, CAC of cone is equal to pi r l. L is equal to slant height. Slant height is equal to L is equal to under root of r square plus h square. Here it is. PSA of cone is equal to pi r into r plus L. PSA of cone is equal to pi r into r plus L. Volume of the cone 1 by 3 of volume of cylinder. So 1 by 3 into volume of cylinder already we know that is pi r square h. Next slant height already I said just now L square is equal to r square plus h square or L is equal to under root of r square plus h square. Now coming to sphere. So CSA of sphere or TSA of sphere. CSA and TSA both are same for sphere, that is 4 pi r square. And volume of the sphere is 4 by 3 pi r cube. Volume of sphere is 4 by 3 pi r cube. CSA of hemisphere. CSA of hemisphere is half of CSA of sphere, that is 2 pi r square. TSA of hemisphere is 2 pi r square plus one more face will be, that is circle shape, pi r square. So 2 pi r square pi r square is 3 pi r square. So CSA of hemisphere is 2 pi r square. TSA of hemisphere is 3 pi r square. Volume of hemisphere is half of the volume of sphere. So that is 2 by 3 pi r cube. So these are all the formulas which are there in mensuration in 10th SSC note textbook. So if you learn these formulas, so you can do any question from the textbook. Okay, so learn carefully and understand and learn and remember. And I'm requesting you all, please like and subscribe. Thank you.